By contrast with arc length integrals and integrals of massive curves, one of the things that we want to be able to do with curves is total up kind of a change in energy from point to point. That leads us into what are called line integrals. And to do that, we first need to talk about what a vector field is. So a vector field in 2D is a function with 2 inputs and 2 outputs, and in 3D it's a function with 3 inputs and 3 outputs. What it does is at every position inside space, it assigns a vector at that point. So we've got, for example, these two examples of vector fields in 2D. Here on the left, we've got a function f of xy is equal to x comma y that takes in any position like 3, 4, and it outputs a vector 3, 4 that points in a certain direction with a certain magnitude. And these vary as we move from point to point. So we've got this nice plot below it that's drawn from Mathematica vector plot function. On the right-hand side, we've got a different vector field, f of xy is equal to minus y comma x, that changes in a different way. You can see that there's some qualitative difference between these pictures. One of them is kind of expanding away from the origin and the other is kind of rotating around. They have different properties and we like to have some tools for analyzing those. So one of the ways that vector fields show up is in studying motion. So maybe there's some fluid in 2D or some gas in 2D or 3D or electric current or something like that that we're measuring. And it changes depending on what position we're at. They can also measure other physical concepts that aren't quite as direct, like the concept of a magnetic field. And we've also talked about gradients of a function. If we've got a function, we can take its gradient, and at each position, we get a vector that tells us where the fastest direction of increase of a function is. What we'd like to do with these is we'd like to study some qualitative aspects of it. The two important ones that we're going to talk about today are divergence and curl. Divergence is a concept that measures expansion and contraction of a vector field. Is if we've got a gas, is the gas getting more concentrated, less concentrated, or is the flow in equal to flow out? And curl measures something called rotation. If we've got an object that's trapped in this vector field, is the vector field going to give it some spin? What direction is it going to make it spin? And so on. So those are the main things we're going to be going over today.